Hello everyone. Today we are now going to discuss about the flow network. What is a flow network? Flow network is nothing but a graph. This is a graph, and with associative some, it is associated with some flow. These are the flow. Here, these 11/16, 12/12. This special notation is f of uv slash c of uv. Okay, this is not a division. So f of uv, that is flow from vertex u to vertex v, and the edge from vertex u to vertex v, the capacity is c. So 11/16, that is from start node, from the source S to V1, the capacity is 16. That is, we can transmit 16 amount of any material from source to node V1, and the flow is current situation. Current situation is we are transmitting thus 11 unit of flow from S to V1. Okay. Now here the flow network has two constraints, two conditions. So first condition, what is the first condition? The first condition is that f of uv must be less than is equal to capacity of the edge c of uv, and this must be greater than 0. The flow, that is flow of a edge from u to v must be non-negative, and it must be less than equals to the capacity. The second condition, what is the second condition? The second condition, the first condition is the capacity constant. The second condition is the flow conservation. What is the flow conservation? The flow conservation says that summation of f of uv is equal to summation of f of vu, where all the v that belongs to v and v belongs to v. So it says that if u and v are, if u for all u that belongs to the vertices of the graph, if these are not the source and the sink, here this is the source S and this is the sink, destination T. If these are not the source and sink, that is the intermediate vertices, then the flow in, the amount of flow in a vertex is equals to amount of flow out in the vertex. That is, if this is the vertex U, then amount of flow in is just equals to the amount of flow out. So this is the so this second condition is the flow conservation constant. Okay, so there are two constants in a flow network. So flow network is nothing but a graph. So flow network is nothing but a graph G with vertices and edges having the capacity C of uv greater than is equal to 0. Okay. Now we will introduce the terminology residual network. Residual network. Residual network. So what is the residual network? A residual network is GF with all the vertices same as in the original graph, and the edges are EF. So residual network is nothing but the original graph, but where we can increase the flow. Okay, where we can increase the flow, but it must satisfy the capacity constant and the flow conservation constant. Okay, and what is an augmenting path? Augmenting path. Augmenting path is P that belongs to a residual network starting from the source it's starting from source S and aims at destination sink T. Okay, so augmenting path is any path in a residual network where we can increase the flow from start node to the destination node. Okay, now so in residual network, what will be the residual capacity? CF UV. The residual capacity is C of UV, starting from vertex U to ending at vertex B. So C of UV is equal to it's the edge's actual capacity minus the flow from U to V. So C of UV minus flow of UV. That is, this amount of flow we can increase in the residual capacity, rather in an augmenting path starting from source to the destination. Okay, so we can write C of F UV is equal to, there is a log, if UV belongs to the graph, then we can say that C of UV minus F of UV. If UV belongs to the vertices of the graph, original graph G, or F of VU or F of VU if the reverse direction graph, the reverse direction of edge exists. If of VU belongs to, if V of this belongs to E, so we can replace this with E. If UV forward direction belongs to the edge, then we can increase the capacity with the amount C of UV minus the flow, capacity minus flow. And if the reverse direction, if the reverse edge exists in the set E, then F of V U and 0 otherwise, if there is no edges exist in the graph. So this is the residual capacity. This is the residual capacity. So we will see with the help of an example. Okay. So this is the graph is given. We have to find out the residual graph of this given network. So let the augmenting path. Let us choose the augmenting path. Starting from S to T. This will be an augmenting path. Let us choose arbitrarily an augmenting path S2, V2, then V3, then T. So S to V2, then V3, then D. Here from S to V, the capacity is 13 and flow is 8. Okay. Then V2 to V3, there is a edge, there is a direction of the edge V3 to V2. With the capacity 9 and the flow is 4. So we can increase this, we can increase the flow in this particular edge with the amount of 9 minus 4, 5. Then V3 to T, the capacity is 20 and the flow is 15. So we can increase V3 to T the amount by an amount 5. Okay. So first construct the residual graph. S, then V1, V2, V3, V4 and T. So So this is the graph. So here S to V1 amount transmitted is 11. Now if so 11 amount of material is transmitted from S to V1. So this is equivalent. If we flow this particular amount, that is 11 amount from V1 to S, then we can increase by an amount 5. Then we can increase by an amount 5. So the transmitted, this particular thing is called the cancellation. So amount is 11 and we can increase from S to V1, this is 5. Similarly, the amount transmitted from S to V2 is 8. So V2 to S reverse flow is 8, and we can increase this by an amount 5. Similarly, V2 to V1, the amount is 1. So amount is 1. So 1 is transmitted from V1 to V2 for cancellation, and we can increase from the flow from V2 to V1 by an amount 4 minus 1, that is 3. Okay. So 12, that is the flow from V3 to V2, V3 to V1 is 12, and zero amount is to be increased from V1 to V3. So in this way we can construct the graph, that is from T to V3 the amount is 15, and from V3 to T the amount is 5. Similarly 7, so this will be 7 and the amount is increased, amount is 0. Similarly this is from T to V4, the for cancellation the flow is 4, and we can increase by an amount 0. Okay. From V2 to V4 the flow of amount is 11, and we can increase by an amount of 14 minus 11. And 4, this 4 amount is flowed from V3 to V2. So V2 to V3 amount is 4, and V3 to V2 the amount to be increased is 5. Okay. Now we are choosing the augmenting path. First augmenting path, this is chosen arbitrary. S to V2, V2 to V3, V3 to T. So S to V3. For augmenting path, the residual capacity. For augmenting path, the residual capacity formula is residual capacity C of F, and augmenting path is T. So this is minimum of C of F UV, where UV belongs to our residual path P. So this is the formula. Here from S to V2, the residual S to V2, the residual the increased path is 5, C of F, V2 to V3. We are choosing the forward direction. So V2 to V3, the amount is 4, and C of F, V3 to T, the amount is 5. So which one is minimum? Obviously 4, that is V2 to V3. So in this particular augmenting path, that is S to V2, V2 to V3, V3 to T, we can increase the flow by an amount 4. That satisfied the flow conservation as well as the capacity constant. Okay. So we can increase up to 4 amount of flow. So the new network will looks like this. So the new network will looks like this. So here the amount is increased. Here the amount is increased. It is 8. This 8 is increased by 4. So this will be the flow will be 12. Okay. So 12 flow is from S to V2 out of 13 capacity. Similarly, as we increase the H flow by an amount 4, and the flow is V3 to V2, the flow was 5, this 5, and we increase the flow by an amount 4, so this will become 9 out of 9. 9 out of 9. Next, 15 with initially V3 to T. So by an amount 4. So this will become 90. So this is the next network. This is the next network. After applying the residual, after adding the extra flow, in the residual network, we are getting the next network. Okay. Thank you.